Thanks, Bibi. So welcome back, everyone. Good morning, good afternoon, good evening, good day, depending on whereabouts you're based. So as Bibi just mentioned, this presentation is going to cover developing Android applications for the HD4000, which is our heads-up display. So this is the agenda for this presentation. So the first thing we'll do is we'll give you an overview of the hardware itself, so a product overview for those of you that haven't seen it before, and maybe for those of you that have, you'll see some specifications and some features there you weren't aware of. So we'll go through the features and then we'll talk about some potential applications that you can use the HD4000 in. Then we'll move on to some sort of high-level design considerations, so the things that you need to bear in mind when you're developing applications, and specifically the screens to display on the HD4000. And then we'll talk about some text rules and some icon rules specifically as well. Then once we've got a high-level understanding of the hardware itself and the things we need to bear in mind when we're developing screens for the HD4000, we can actually get into the API usage. So I've broken down the APIs contained within the SDK into 3 categories, so basic, intermediate, and advanced. But these categorizations are all within the context of the SDK. So even though I've put the advanced category down there, it should all be fairly straightforward. It's just advanced in the context of the SDK. Then for the penultimate section, I want to talk about a HUD interface utility that we've created. So this is an alternative way of interfacing or sending screens to the HD4000, and that's based on the intent architecture. So using intents to display information on the HD4000 rather than using the SDK APIs. And we also have a version 2 of this SDK, which we're just preparing for release. We expect to see this released officially in the next couple of weeks once we've finished our final beta testing. But I want to just give you a quick preview of what to expect in that next iteration of the SDK. So let's get straight into it then, and let's have a look at the hardware itself. So this is our HD4000 that you can see on the screen here, mounted to a pair of safety goggles. So as with most of our products, it's ruggedized for industry, and it's been given an IP67 rating, weighs less than 30 grams, will resist a 1.5 meter drop to concrete, and will operate between -20 and +50 degrees Celsius. So well ruggedized for industry. All of the variants of the HD4000 come with a microphone and a 9-axis position sensor integrated within the unit itself. So this is the unit here. This is the mounting bracket onto the glasses. And inside this unit here, you have a microphone and a 9-axis position sensor. It can be mounted either over the left eye or the right eye with a simple mounting bracket that you can see here, and that will fit off-the-shelf eyewear. So every human on Earth will have a dominant eye, will either be their left eye or their right eye, and we recommend having the HD4000 over your dominant eye. So you can swap this around and have it over the opposite eye if you needed to. It also has a bracket at the back here, which I think you can see, which allows the HUD to be flipped out of view when not in use, so you can have an unobstructed view. So it also comes with a USB cable, which we can see here, and that is what provides both power and communication. So there's no battery included on the HD4000 unit itself. It draws the battery from the device that it's connected to, and of course, all communication goes through that USB as well. This down here is our proprietary see-through optical engine. So this is where the content is actually displayed to the user. It gives you a 20-degree field of view, and the resolution for this here is 640 by 400, and it's an OLED display. We have 2 variants of the HD4000, the Mentor and the non-Mentor version. The only difference is that the Mentor version comes with a front-facing 5-megapixel camera. So that's an optional extra, and you can see here that is the camera integrated in this Mentor version. So some key features then, some of these are repeating what's in the previous slide, but a full shift battery life, obviously that depends on the device which it's connected to, but typically if you plug it into one of our newer devices, say a TC26 or an MC93, for example, you're likely to see a full shift of battery life. Again, it's been appropriately ruggedized, so I won't repeat that, but IP67 rated and so on. It's nice and easy to clean with multi-user hygiene considerations. The unit itself can be detached from the glasses, and then the glasses can just be cleaned as any other standard off-the-shelf eyewear would be. And it provides ease of integration, so only one application is needed for both the device-only use and the device plus HUD use. So you can have your applications function both with and without the HUD. The unit itself is lightweight and balanced with optimal optic position. As I mentioned, you can accommodate both left or right eye positions depending on which one is your dominant eye. And there's also prescription glasses support depending on which off-the-shelf eyewear you use. And then finally, there's no staging or IT management required. That's because there's no wireless radios or communication to certify and maintain. And as it draws all of its power from the device, there's no battery charges or anything like that. So quite simple to introduce this into your production environment. So that's an overview of the product itself. So now I wanted to talk about some design considerations, so some things to bear in mind when you're developing screens for the HD4000. So some general rules then. The HD4000 display, as I mentioned, has a resolution of 640 by 400, so that's not a lot of room to work with. So the key is to keep layouts simple. You also want to try and center content as much as possible. So you want to be clear, concise, to the point, and try and keep your information in the middle of the screen. We recommend using a dark black background, preferably black. Given that the HD4000 uses an OLED display, if you use a black background, OLED displays simply turn off the pixels to display black. So by virtue of the fact you're using an OLED display, if you have a black background, you will save battery. Fairly intuitively, you would avoid using a white background, typically much harder to see in bright light. And we also found that you shouldn't use blue as the main color, as this can cause eye strain after prolonged use due to the low contrast ratio. Can't imagine that blue would be the first color a developer jumps to use as their background color, but if it was something you would consider, we recommend against it. We also, in general, try to recommend using icons where possible. And if you can't use an icon, then we recommend using single words with direct intent. So the key is just to be clear and concise. So if you need to use words, use simple commands like cancel or confirm, and so on and so forth. So on this slide, I just have sort of a visual representation of the rules I've outlined on the previous slide. So the first two examples here are examples of things that you shouldn't do. So black text on a white background is, we recommend to avoid it. It's going to be hard to see that outdoors, and it also increases battery consumption fairly significantly. And then again, using blue as the background, we advise against due to the low contrast ratio and the potential to cause eye strain. These two examples on the right-hand side then are examples of well-designed screens. So in an ideal world, most, if not all of your screens would look something like this. You have clear header text and body text, well separated, centered, and concise, so not long blocks of text. Of course, there's always going to be some use cases where you simply need to provide more information to the user. And if you do need to do that, just make sure that the text is big enough for the user to be able to read, and that it doesn't overflow or require the user to interact with it. You just want to try and fit it into the one screen if you can. So some rules specifically for text then. We recommend the text size should be about 36 SP. Headers and titles should be at a minimum of 32 SP, but we recommend 40 SP for headers. And the minimum text size you should use for any of your screens for any purpose is 14 SP. Anything below this size is typically illegible and wouldn't be readable to the user. We've also found that the typeface Roboto works well, looks good on the HD4000, but that's just a recommendation. Of course, if you find a better typeface or one that suits your design paradigm slightly better, then feel free to use that. So again, in the same vein, I just have a visual representation here of the rules in the previous slide. So this is a very straightforward example. White text on black background is your go-to. Yellow text on a black background then can be useful if you need to denote some sort of warning to the error, or if you need to bring their attention to something, then yellow on black is a good way to do that. In a similar vein, red on black, I've put this down as use with caution. The contrast ratio between the red and the black isn't great. It can be a little bit hard to discern the text from the background. We wouldn't recommend using this often, but given that instinctively red is associated with an error, this can be good to be used sparingly in and around your app to denote an error to the user. So it's less important for them to read the specific text, but more so just to show the user that an error has occurred. Perhaps they picked the wrong item or placed it in the wrong tote. And then finally, blue text on background, in the same reasoning they gave in the previous slides, the poor contrast ratio doesn't really work well on our HD4000 screens. Again, I can't imagine blue text on a black background would be your go-to, but if you were considering that, we would recommend avoiding it. And then finally, for the design considerations, we have some rules for the icons. The icons cannot be smaller than 32 by 32 pixels, and we recommend the size should be at least 48 by 48 pixels. You want to use at least an icon's width and height to separate multiple icons. You don't want them to be too congested, because then it can be hard for the user to discern where one icon ends and another starts. And again, as a recommendation, we would recommend material icons from Google. These are open source icons that you can use in your application. There is a huge resource at that link there. But of course, if you have a different icon library that you prefer to use, feel free to do so. So again, just another visual representation of the rules I've outlined. So this is an example of a well-designed screen. You can see the icons are nice and large and easy to see, white on black with appropriate spacing between the icons. And then over here, these icons are too small, placed too close together. So we would recommend avoiding this and trying to design your screens closer to this. So that's sort of some high-level considerations covered off. So now let's get into some of the more technical details and actually look at the APIs within the SDK. So the first couple of APIs I'm going to tackle are some of the basic ones, just to sort of introduce you into the idea of the SDK, some of the APIs available within the SDK. So the first API, and this is by far the easiest API to use, this would be my recommendation if you've just picked up a HD4000 for the first time, you've got the SDK in your hands and you want to try it out and see what it does, this would be the API to do that. So all of these APIs, I just need to preface this quickly, all of these APIs are all called on an instance of the Zebra HUD object, and you just create that as you would any other object in your application, and then you call all of these APIs from that instance of the Zebra HUD inside your application. So as I mentioned, the first and easiest API to use would be show message. So this API does pretty much what it says on the tin. We pass through two parameters, a string for the title and a string for the message. And then this pre-canned design here will display on your HD4000. And obviously the text will be replaced by the parameters that you passed in to this API here. So your title will be the string that's passed in as the first parameter and your message the second parameter. In the similar vein, if you wanted to display an image rather than some basic text, we can call the show image API, and that requires an image in the bitmap format. So again, that's called on an instance of the Zebra HUD. And of course, because it takes a bitmap as the parameter, then image resources will need to be converted to the bitmap format before they can be displayed. So typically, I would recommend using an image processing library, something like Picasso or Glide, to convert your images into bitmap format. Bitmaps are quite memory intensive to create, and there can be some complications in there when you're creating and handling bitmaps in memory. But if you use Picasso and Glide, they pretty much take care of all of these complexities for you on the background, and they're well supported, well established libraries. So I'd recommend using them if you're working with images with the HD4000 SDK. And then the last API under the basic API umbrella is capturing an image. So there's 3 steps to this. We need to start the camera capture. We need to retrieve the image that is being captured by the camera, and then we need to stop that camera capture when we're happy with it. So the first thing we'll do is we'll call start camera capture, and then this will immediately start capturing images. Those images are returned sequentially into the on-camera image callback, which can be registered in the onResume callback. So by calling zebrahud.onResume and passing through an instance of this event listener interface, we would then be able to receive our on-camera image callback, and it will provide us the image in bitmap format. Once we've received that image and we're happy with the result, we can then call stop camera capture, and there will be no more subsequent calls to the on-camera image callback. And again, that image is provided to us in bitmap format, so you can then go ahead and leverage something like Glide to put that into an image view, or maybe save that to disk or post that up to a server, or whatever your use case may require of you. So moving on then into intermediate API usage, and under this umbrella, I've put 2 APIs, but they are used in conjunction with each other. So these APIs are the create HUD view and show HUD view APIs. And essentially, these allow you to create HUD screens using layout files, the same layout files that you would use to create Android activities. So the first thing that we do is we call the create HUD view method, and we pass through the layout file that we want to create a view from. So this is essentially taking a layout file and inflating it and putting on some extra parameters there to make sure that view is compatible with the HUD. And then that returns us a view object. We can then do whatever we would normally do to a view object. Say if we wanted to change an image view inside there and change the resource of that, if we wanted to change some of the text contained within that view, we could do. And then once we've designed that view, we can call the show HUD view method, and then that will actually pass that view through the SDK up to the HD4000, and it will display that content on the screen. So this allows custom views to be displayed on the HUD with relative ease. And if you're a developer with an Android background, this would be the most intuitive way to create layouts for the HD4000. So when we talk a little bit later about the intent interface utility, that's leveraging these 2 APIs here. So on this screen, I have sort of a breakdown of how you would actually use these APIs. So it puts the previous slide into a bit more context. So on the left-hand side here, we have a typical Android layout file. So on the left-hand side, we have the XML representation of that layout file. And on the right-hand side, we have the visual preview. So this is a preview I've just pulled from the Android Studio development environment. We can see here contained within this XML, we have a linear layout, which is a layout which orders its childs from top to bottom. And then we have an image view, which takes up 90% of the screen, and a text view, which takes up 10% of the screen. So this is quite a simple, basic layout, but obviously this could become arbitrarily complex depending on your particular use case. And then over here on the right-hand side, we see how we would actually use these APIs and display this content on the HD4000. So the first thing we need to do, and this before we use any APIs, is to create an instance of the Zebra HUD object, which we do there. We can then create a view object passing through our layout file over here to the create HUD view API, and then that returns us our custom view. So this is an object representation of this over here. We can then use standard Android APIs to extract components from these views. So I've extracted the image view and the text view using the find view by ID APIs. And then I can modify those views depending on what I need to do. So in this case, I'll set the image to vector called IC success, which is a tick, and then down the bottom I'll change the text to some custom text. So that's now configured our view with the data that we need to display, and it's ready to be passed to the HUD. And then I simply call show HUD view on an instance of the Zebra HUD and pass through the view as the only parameter, and then this will be displayed on the HD4000. So I think if you're an Android developer and you're well used to designing activities and different screens for your mobile applications, then this would be the most intuitive way to extend that functionality and start designing screens for the HD4000. So finally, then, I wanted to talk about some more advanced API usage. But again, this is all within the context of the SDK. So hopefully these APIs should all be straightforward, and you should have a firm understanding by the time we've gone through the slides. So the API that I want to talk about here is using what's called a JSON image model, or JIM for short, to basically design a HUD screen. So using the JSON image model, you can generate HUD screens using JSON files. If you were to use this technique, then you would have one JSON file per HUD screen. So say if you had a workflow that needed to show 5 HD4000 screens, you would have 5 corresponding JSON files, one for each of those screens. So each JSON file contains multiple widgets, and those widgets are essentially what make up the content of the display. And each of those widgets can either be an image or a text widget. So each widget is essentially a view on the HUD display. We show the screen onto the HD4000 using the show JIM API, and we simply pass through a string representation of our JSON, and we of course call that on an instance of Zebra HUD. If we want to leverage using image widgets as well, we need to use the overloaded method and not just pass through the JSON representation or string representation of the JSON. We also need to provide the images directory. So you see in the next few slides, when we define a image widget, we provide the relative file path, so just the end of the file path. And then when we call the API, that's where we provide the absolute path so that the SDK knows where to look for those images. Both of these methods return a byte array, which represents the display content. So once you've passed that JSON through to this API, the SDK will go and parse that JSON, build the view from that JSON, and then it will return that view to you as a byte array, so you can have a reference of what is actually being displayed on the HUD. Perhaps you want to mirror that on the device, or save that screen to the device, or push that to a server, whatever your use case demands. So in the next couple of slides, I'm going to show you the actual schema for this JSON image model, and then I'll try and show you 3 or 4 different examples of how you would actually design screens using this schema. So hopefully when all the slides are finished, it all ties together and makes sense. So I've had to split the schema into 2 slides just because it wouldn't fit on a single slide and it would be illegible. But just consider this the top half of the JSON schema, and then on the next slide, just append it to the bottom. So these are the sort of what I would call top level JSON variables that you can include, which define some sort of overall specifications for the HD4000 screen. So the first thing we've got there is a version number. At the moment, this is just an enum with only one option, but this gives us here the ability to update this JSON image schema without having to update the SDK if we needed to. At the moment, this will always be 1.0. And we have the options to show a frame, and this would literally just put a border around the HUD screen on the view, and it can help separate, the real world from what the user's actually seeing on the HD4000. If we set this Boolean to true, then we have the option to provide a frame color as well, and that will just determine the color of the frame. This relies on Android APIs, and it uses the color.parseColor API. So any color supported by this API is subsequently supported by frame color and would be a valid entry into this here. Then finally, we have the ability to resize the screen. So if we wanted to scale everything up or down, we can do so by passing in one of these values here. These are the 5 supported values. And of course, if you omit this, then no scaling will occur. So this is the second half of the JSON image model schema, and this is where we actually define our widgets. So each JSON image model file will contain an array of widgets, and that array will contain one or more widgets of either text or image type. And each of those widgets have these properties down here. So I'll quickly go through each of these one by one and try and explain what they do if they're not obvious. So the first one then is whether or not the widget should be visible. So Boolean true or false will either hide or display the widget, and that corresponds to the view.visible and view.gone APIs. The sort parameter here, this variable, is very important. So when we declare multiple widgets inside this widget array, we need to give them a sort value so that the SDK knows which views to place on top of each other. So if we were creating a PowerPoint presentation, for example, this would relate to the, when you right click an image and you say send to back or bring to front, that is essentially what this sort value here is doing. So if I have one image widget and one text widget, and I give the image widget a value of 0 and the text widget a value of 10, the text widget will subsequently be placed in front of the image widget. So I can have one as sort of a background and then one overlaying the other. So to summarize that, it's the Z position, and the higher valued widgets are overlaid on top of lower valued widgets. You should see this in action in the examples I've got in the coming slides. We have a type enum, and this is either text or image because these are the two widget types that are supported. This defaults to text, so you only really need to include this if you want to use an image widget. The data then, this depends on what the type is. If the type is text, the data will just be the string to display. If the type is image, then it can be either the path to the image, and this is the relative path, remember, or it could be a base 64 encoding of the image itself. So just depending if you want to reference an image on the device so that you can change that as time goes on, or if you want to statically declare that image inside the JSON file, there's two options for you there. The next two properties here, position and position point, do what you would expect, and you can choose either one of these to declare where you position your widget inside the screen. So essentially the difference is that the position property here, it places, or it uses 0, 0 on the axis as the reference point, so bottom left, whereas position point uses the center of the screen as its reference point. Both of these are arrays, and the array needs four numbers inside. You need the X position, the Y position, and then the width and the height of that widget. And these numbers can go from 0 to 100. So for example, 5, 5, 90, 90 would provide a 5% border from full screen. The bottom left of the grid are from the center of the grid. So you have your center X and center Y positions, and then your width and height. So 50, 50, 10, 10 would create a 10% width height box with its center point in the middle of the screen. The next property then is lines, and this is only applicable if you're using the text widget, but it says how many lines of text should be displayed. Color then is the text color, or if you're using an image widget, it's the color applied to that image using the Android portaduff.mode.multiply API. And again, this string is parsed using the color.parseColor API. So any colors supported by that API are subsequently supported by our API as well. The background color here is, of course, what you would expect is the background color. Bold is whether or not the text should be bolded. Image scale then, this refers to the image view.scale type enumeration. So one of each of these values here will scale the image in certain different ways in order to fit the HUD screen. And if you wanted to find out more about what each one of those does, then you can have a look up image view.scale type on the Android developer documentation, and you'll be able to see what that would do with the images. And then the final property we have down here is gravity, and that's just where the text gravity is applied, so left, right, or center. I appreciate that's quite a lot of content to sort of all take in, just through a presentation. So hopefully these next few slides with some actual examples puts that all into a bit of context. So over here we have the JSON image model that I've created, and then on the right-hand side we have the image representation, or what you would see on the HUD screen if we were to pass this JSON image model through our API. So the version, as I mentioned, will always be, for the time being at least, 1.0. And to keep things simple, I've omitted the show frame or scale values. And then down here, we can see I've declared an array of widgets. And inside that array, I have one object. So I've put in a sort value of 70 there. This is only important if there is more than one widget. So it doesn't matter where it's placed on the Z-axis, given that it's the only widget to be displayed. I've included a note property here, so this will be ignored and not parsed by the SDK, but it can be quite useful if you're creating an array with lots of different object widgets inside. To be able to track which widget is which, this note property here is quite useful. I've put the position through as 0, 50, 110. So 0 on the x-axis, 0 on the y-axis, 0 on the x-axis, 50 on the y-axis, 100 width and 10 height, and then that displays a small box down here. So we can see that the data is remove hubcap label 3, which is the text, and then the background color is just off black, and it's been bolded as well. But in the same vein, if I wanted to do the same thing, but rather than displaying a text, I wanted to display an image, then this is how I would do it. So the top properties there stay the same, the version and the show frame, and then I've just changed the object inside the widget. And the key changes here are that I've included the type value. I've set the image scale, fit XY, so this just means scale the image so that it fits the size of the screen. And then the data here is the relative file path to the image. So if you remember before when I said that you call the API, you pass through the gem, and if you wanted to show an image, you need to pass through a second parameter, which is the directory for those images. That would be the parent directory of this value here. So if this was an images folder inside the SD card inside your application directory, then you would pass that value through as the second parameter, and then this data will be appended to that parameter that you've passed. So I've given this a sort value of 10. Again, that's irrelevant at the moment, but in the next slide, you're going to see why that's important. And I've given it a position of 0, 0. So start the image down here and then fill the screen 100 by 100. So on this next slide, I've combined the two previous objects and put them into the same array. So we can see here the first widget we have is the image widget, which is this diagram of an engine. And then down here, we have the text widget, which is this text at the bottom. So the key thing here from this is to see now the importance of the sort value. So by giving the image a sort value of 10 and the text a sort value of 70, I've placed the text in front of the image. So the image goes at the back and then the text comes through to the front like that. It's arbitrary that I've chosen 10 and 70 as the numbers. It could quite easily be 1 and 2. It could be 10 and 100. All that matters is that the sort value is higher than the widgets it needs to be placed on top of. Then if I wanted to get a little bit more complicated, I can include this extra image down here, which is this red arrow, and I've included this down here. So the sort value is 10, which is the same as this text widget. So I know that this is okay because the text widget only takes up this much of the screen and the image will be placed above it. And I know that they will never overlap. If they were going to overlap, then I would need to increment that sort value to make sure that this arrow is placed above here. My position is also very specific. So I've given it an X value of 37, Y value of 44, and I've said 25 and 25% should be the size of that. So you can see you can get very specific and create fairly complex screens using a JSON image model with relative ease. So you could continue to add objects inside this array to make this screen more complicated if you needed to. And then on this final slide, I just show an example of how you would put a frame or a border around the JSON image model. And that would be done here. So putting show frame as true, and then the frame color is green, it would just put a green border around the HUD view itself. So moving on then, and I wanted to talk now about the HUD interface. So the HD4000 intent-based interface was essentially developed because popular existing apps, so things like Enterprise Browser from Zebra or Velocity from Avanti, well-established products like these are going to find it difficult to integrate this SDK quickly. They're not necessarily difficult to integrate the SDK, but to do it in a quick manner without having to rewrite too much of their code base. So the interface app is designed to remove the majority of the work required to integrate the HD4000 into existing applications. And it does this by leveraging the standard broadcast intents mechanism to interface between the HD4000 and any other application which wants to send data to that HD4000. So it runs as a foreground service. And it needs to do this in order to be able to listen for these broadcast intents that may be sent out by other applications. And this foreground service essentially manages all SDK functions and connection to the HD4000. So by using this utility, any other application doesn't need to be aware of the HD4000. It doesn't need to interface with it directly in any way. The service manages all of that for you. So there's no need to write a native Java application in order to leverage the HD4000. But once a broadcast intent is received by this service, it will consume the intent and whatever extras have been included in there, and then it will create a representational screen from that intent, and then it will display that onto the HD4000. This also comes with quite a useful optional screen overlay. So obviously, if you were to go to a boardroom and you wanted to demo the HD4000, only one person is going to be able to wear that unit at any given time. If you wanted to show everyone else in the room what the person wearing the unit was seeing, then you could enable this overlay on the device, and then you would have a representation on your device screen of what the user is seeing on the HD4000. So this was actually developed in conjunction with Avanti. It was an idea that was spawned from one of our SKOs, and as such works well with Avanti, and it's also been tested and working with Enterprise Browser. And I'm confident to say that any application that supports the intent-based mechanism, so an app that can send intents, broadcast intents, will be able to interface with this service and subsequently interface with the HD4000. Now I just want to go through some of the things that are supported by this intent application and how you would build the intents to use this application. So the simplest thing you can do is just to display a single line of text. This is the action that you would use for the intent, and these are the extras that you would include within that intent. So these are basically just defining what you would like the text to look like, and of course what the text would say. And I've put down here what APIs these rely on so that you know what information is supported. And then an example I have down here of how you would send an ADB command in order to test this. So you can see here the action is to display the text, and then I just have several different string extras to say I want to pick the item, I want the text color to be black, size 12 text, place it in the center, and have a little background color of yellow. You can see here, this is what it would look like on the screen of the device if you had the overlay enabled. And if you didn't have the overlay enabled, that's what you would see on the HD4000. In the same vein, if you wanted to display multiple lines of text without having to send multiple calls one after each other, you can do that. And you would send the same action, but you would change the extras and you would use text.array instead, and then you would pass through your text in this format down here, and each one of these formats would denote one line of text. So you have your data, the text color, the justification, background color, and size. You separate all of those with a tilde character, and you end it with a pipe. And then you can copy and paste that, that format indefinitely for as many lines of text as you want. So we can see down here, I have the text array extra. I have my title text up here, which is this. I then place a transparent line so that I can have a bit of a gap. And then I have three more pieces of text, which are displayed down there. You can see that's white text on a black background. I wanted to display an image that's also supported. This would be the action. And then the only extra that is required is the image path, but you can override the width, height, and scale type values. So this will default to 640 by 400, which is the size of the display, and the scale type will default to fit XY, but you can override that using any of the scale types supported in the Android API. And then this is what as an example command would look like. And I've omitted the width, height, and scale type values here, and I just passed through the image path. So that is the absolute path of SD card download printer.jpg, and then it will display that image on the HD4000. The next intent that's supported is the display text and image intent. So if you wanted to combine displaying text and images all into a single intent, you can do that, and you would just pass through the extras as I've outlined in the previous slides, but you would combine those into one intent, and the action would be display text and image. So this API can be used to place an image in the background and then overlay some text on the top of that, and that's a single line of text. If you wanted to display multiple lines of text, then you would simply do the same thing as with the text intent and omit the individual extras and replace them with the single extra here, text.array, and follow the format that we discussed in the previous slide. So you can see there that gives you the ability to send through a background image, a title, a big break in between, and then text at the bottom of the screen. So it's a little bit fudgy that you need to push through a transparent, but that's what gives you the gap here, and it gives you the granularity of control of where you place that text on the HUD screen itself. Finally, then we also have support for the GIM. So if the JSON image model piqued your interest and you thought that's how I'd like to design my screens, that's also supported by the intent interface. So you just call the display GIM action here, and there's two extras. So it's the JSON to display, and then an optional extra of the images directory, which is the directory for relative path images. So if you want to include image widgets, then you would need to pass that extra as well. And there's an example of how that would work. So you can see here I have the second string extra GIM image directory as SD card download, which is the prefix to this data here inside the GIM itself, which is printer.jpg. So by sending this ADB command, I will send this JSON to the HD4000, and the SDK will look for printer.jpg under SD card download. The last couple of
James, we lost your screen for a second.
Yeah, I think I'm back. Let me reshare my screen. Sorry about that. It's handy that it came straight back. Anyway, sorry about that. So the last three categories of intents here are basically some sort of management intents. So if you wanted to clear the display in between different intents, here's how you would do so. And you just send the clear intent. Alternatively, if you didn't want to, verbosely send an intent in between the different displays, then you can prefix the data field with a caret symbol. And then the service, the intent interface, will parse that caret, it will clear the display, and then it will go ahead and display whatever it is that you've passed through in the next intent. So for example, if you wanted to display an image, but you wanted to clear whatever was previously on the display, then you would push through the caret as part of the image.path variable. If it was a text widget that you wanted to display and you wanted to clear the previous screen, then you would place this caret symbol before the text that would be displayed. And then finally, you have the option to toggle the overlay, and this is just the overlay that's on the device screen for boardroom demos and things like that. So I think we're coming towards the end here, but these are just the last couple of slides. So I just wanted to talk very quickly about the next generation SDK, show you or just quickly highlight the changes that you can expect to see. And then I have a quick video of a customer who's actually integrated this HD4000 version 2 SDK in their application, have created quite a cool remote working or remote assistance application. So as I mentioned, version 2.0 of the SDK will be released in coming weeks. And the key focus of this SDK is around live streaming and being able to draw over the HD4000 in real time. So all of the new developments in this SDK are essentially based around improvement to the camera functionality. So on this next slide here, I have an example of a partner called Help Lightning, who's been working closely with, and they have a fully released remote assistance application. It's available on the Play Store, which works with our HD4000, and it's quite a cool little demo. So I'd like to show that in action.
No audio coming through, James. If you want to.
Oh, sorry, thanks for letting me know, Ian. Thought I'd shared my screen sound. So yeah, as we can see there, we have an operator in an office somewhere, this lady here who's using one of these pads, and we can see that this camera is being used to display the remote operator's hand or movements over the user's HD4000. So this user here is receiving live information in his HD4000, and likewise the remote assistance operator is receiving a live camera feed from that worker down there. So this is what the remote assistance provider will see on their screen in their portal, for example. And you can see there that the remote assistance provider can then overlay and draw onto the HD4000 screen to pinpoint exactly what it is that this operator needs to do. So it's almost as if they're in the room with them and providing them very accurate and precise guidance, and they can watch them do that the entire time. So apologies for the sound not working, but again, this is something that's available on the Play Store at the moment. So if you have a HD4000 and you type in Help Lightning into the Play Store, you'll be able to get set up and running with that. So that actually brings us to the end of the presentation. I think we're pretty good for time. So let me just have a look to see if there's any questions that come through. So I can see one here.
Yeah, and there are 2 questions answered by Ian, but maybe just share the answer so everyone gets to, we get to share the knowledge.
Okay, so I'll just quickly vocalize the responses Ian gave. Thanks for that, Ian. So Klaus asked, what is the solution if the user is a spectacle wearer? We have an alternative mount available for attaching to spectacles. So we're not sure if that is released yet, but there should be some samples available if required. If you get in touch with your account manager, I'm sure they'll point you in the right direction. How are firmware updates for the HD4000 managed, and can this be accomplished via an MDM? So Ian said there that there are no firmware updates on the device itself, as it is simply a display. All updates are on the host device side, e.g. and any middleware. So thanks for that, Ian. So now some open questions. So suppose I want to use the HD4000 to be optional with my app. Do I need to do anything special in terms of checking if the HD4000 is connected before instantiating the Zebra HUD object or trying to display an image? How do I handle the user connecting or disconnecting the display while the app is running? So inside the SDK, we have an interface called the Zebra HUD Events Listener, where the camera images are displayed. There's also a separate callback inside that interface called onConnected, and that will be called every time a device is plugged in, or the HD4000 is plugged into a device or removed from the device, and then you'll be informed in that callback. So if you need to perform some sort of logic when the HD4000 is disconnected, you can be notified in that callback, and then you can handle that however your use case demands that you handle that. There's also a utility method inside the Zebra HUD object called isConnected, so you can check that on the fly without being inside the callback if you needed to as well. Ben's asked here as well, what about the microphone? So the microphone is controlled using standard Android APIs. So in the same way that you control any other external mic, you would use that same method for controlling the microphone on the HD4000 as well. So if there's no other questions coming through, I can't see any. I think the next session we have is the wonderful Ian Hatton, who's going to cover a practical guide to Zebra license installation. So thanks everyone. I hope that was a good talk, and I hope you enjoy Ian's next talk as well. Oh, sorry, I think a question's just come through here. Can the camera on the HUD scan a barcode or QR code within view? So it can't do that live. What you can do is you can have the HUD capture an image, and then you can post-process that image to decode a barcode within the image. Typically, in a real-world scenario, I wouldn't really recommend this, in your production environment. The quality of the image captured and the way the user captures that image usually means that the barcode decoding isn't very successful. It's also quite tedious to make the user actually go and focus their head on a barcode. So as humans, when we want to look at something, we tend to move our eyes rather than our head. But because the HUD is mounted directly on the head itself, you would actually need to move the head to try and capture that barcode, and it's not very intuitive. So technically possible in a production environment, probably wouldn't recommend it as a good use case.